Okay, so for 10.6, I'm going to make just a video that follows along to the actual notes itself. So we're going to learn a couple new theorems with 10.6. We learned a bunch of ways of calculating and actually figuring out what angles were using the arcs with section 10.5, but with 10.6 it's more theorem oriented. So theorem 89 says if two inscribed or tangent chord angles, if they intercept the same arc, they are congruent to each other. So if you see angle X right here and angle Y, if you follow the sides of X out, and then if I use a different color and you follow the sides of Y out, you're going to find that they do in fact intercept the same arc. So Y is getting you arc AB as well as angle X. So if they both intercept the same arc, you can therefore say that those two angles are congruent. The same goes on the other side. Angle A, if you follow that out, is made up of arc XY, and angle B, if you follow those sides out, is also made up of XY. So angle A and angle B would be congruent to each other. With theorem 90, if two inscribed or tangent chord angles intercept congruent arcs, so instead of it being the same arc, we have two angles, angle P and say angle D right here. They intercept two arcs that are congruent. So arc AB is congruent to arc CD. So if those two arcs are congruent to each other by the formula, P is an inscribed angle. So angle P would be equal to 1/2 the measure of arc AB. And D is made up of a chord and a tangent, so angle D would be equal to 1/2 the measure of the arc that makes it up, which is CD. And given that AB and CD are congruent to each other, you can therefore say that angle P and angle D are congruent to each other. All right, theorem 91, an inscribed angle in a semicircle is a right angle. So if you have an inscribed angle, meaning the vertex is on the circle itself, angle C, and it is made up of half of the circle, you know half the circle equals 180. Inscribed angle, the formula goes, it's half the measure of the arc. So if that's 180, then the angle has to be a right angle. And then last and final theorem is 92. It says the sum of the measures of a tangent, that only goes for tangent, nothing else. That tangent angle and the minor arc is 180. So if PT and PS are both tangents, they start from the same external point, then you can say that angle P plus the minor arc, which is the one that's closest to it, TS, adds up to 180 degrees for that. All right, continuing with some of the examples here. So it says in circle O, BC is a diameter and radius 20.5. Chord AC is 40, and we want to find AB. So first thing you need to recognize, A is an inscribed angle. It is on the circle itself. It is made up of the diameter, which means the diameter cuts the circle in half, 180. Therefore, the connection to make is that this is a right angle. If the radius is 20.5, then this is 20.5. Giving us 41, and we can use the Pythagorean theorem to get our AB value, which is left over. Final example, angle P. So angle P, that is made up of two tangents, PA and PB. So the theorem says that that angle plus the inner angle should be equal to 180 degrees. The way that I did it right here is using the previous method, which is a tangent angle. But you can also say that 6x plus 15x plus 33 equals 180. You'll end up with the same result in the end for angle P, and angle P comes out to being 42 degrees. So you have two options. This is number 1, or you can use the new theorem, number 2 right here. So homework here is at the bottom. Make sure that you get those 4 questions done.